Welcome to ClickMyProject.com. The title of our project is An Analysis of Semi-Supervised Machine Learning in Electrical Machines. The abstract of our project is to detect fault in machinery bearings, a critical aspect for ensuring system safety and reliability. The classification aims to distinguish between a range of bearing conditions like inner race fault, outer race fault, ball fault and combined fault, and also healthy baseline. The research addresses that the common challenge they faced due they obtain sufficient labeled data in real-world industrial settings, particularly for fault conditions. Here, semi-supervised machine learning is employed to effectively utilize both the limited labeled data and the abundant unlabeled data available from the sensors and other monitoring systems. Here we use a machine learning based framework for fault detection in electrical systems, mainly focusing on inner race fault, outer race fault, ball fault, combined fault, all these inner outer ball, all those combined, and healthy baseline, in order to ensure that the bearing is working properly in and also in good condition. Now we can see the architecture of our project. Here we collect data sets of bearing, faulted bearing from Kaggle, and we have to pre-process that, handling missing values, doing label encoding. In order to increase the accuracy, the data set should be clean, and furtherly it will be trained using random forest algorithm and SSML algorithm, self-trained algorithm, and the prediction is done, and the flow is the data sets are collected from the Kaggle as a CSV file and proceeding to the pre-processing step like checking missing values, label encoding, such that, and the training model will be done using random forest algorithm, and the prediction is done in a self-training algorithm. It is a semi-supervised machine learning model, and the prediction will be displayed in the web application. Now let's see the demo of our project for fault prediction in bearings. Initially you have to give username and password, which is mandatory for login. For example, I just give hi and register, and it will be directed to the login page, and you have to give the same registered username and password and give login. It will be directed to the prediction page. Here only we are going to predict the fault. Here we have used self-training semi-supervised random forest algorithm. For prediction purpose, it will be displayed here, and its accuracy is 91.45% accuracy we got during training. Let me give the inputs for this. The initial step for the prediction is dataset collection. From the dataset, you can give any inputs for the prediction, and it is already pre-processed dataset, so we are giving the inputs directly. The inputs which I have given here is from our data set, and after entering all the inputs, we analyze fault with these inputs like a maximum, minimum, mean, SD, RMS, skewness, kurtosis, crest and form. By analyzing all these inputs, we will be predicting the fault. Now let's predict fault. Just give predict fault, and the fault will be displayed down as outer race. The outer race is the predicted fault. The accuracy of the model will also be displayed here. Now let's see the overflow of our project. When I click overflow button, it will be directed to the overflow page. Here you can view all the data set. It has a number of rows, columns, missing values. Though we have checked the pre-processing steps, there will be no missing values present here. These are the parameters which we use for prediction purpose. And here is the sample data. I just entered one sample for prediction, and here we can see all the data sets, sample data set, and these are the distribution of fault types. And plot for feature distribution for the parameters which we have seen for which we used for prediction. Those parameters distributions, feature distributions. And this is the correlation heat map and feature importance. How important the features are to predict the fault, and here minimum value is the top priority for the fault prediction. And this is the confusion matrix. These are the plots by analyzing all the input parameters. And let's see the model training, what we have used, architecture, hyperparameters, like that. Here we have used random forest for pre-processing the data types, and semi-supervised learning process. In that SSML we use self-trained model for predicting the fault. Here we will be training 10% labeled data, then pseudo labeling will be done in the data, and the prediction will be done in unlabeled data with confidence. And these are the parameters which we use here. And what are the training steps we use? We will be loading and pre-processing the data set, and we will be splitting the data set for training. Here the major amount of data sets will be used for training, and a minimum portion of data sets are used for testing. And here 10% will be labeled data initially. We will be labeling data, and for generating pseudo labels for unlabeled data, and we retrain with high confidence pseudo labels. This is the procedure which we use for self-trained model. And the accuracy of our model is 91%, and the precision Greek call score will be displayed in here. And what are the target systems, and what are the data set we have used, such that will be displayed in our website. And here is the logout button. When we click logout button, it will be redirect to the login page. Thank you.